to be proceeding to the 2019 AIME 1 problem 14, which is a really short problem. Find the least odd prime factor of 2019 to the 8th plus 1. Okay, so now this one, let's call the prime factor desired. Then 2019 to the 8th must be equivalent to -1 mod p, right? So this is actually pretty clear. So 2019 to the 8th is equivalent to -1 mod p, and this doesn't really tell us anything. So this square gives 2019 to the 16. But we have to be careful over here because it's not always the case that when 2019 to the 16 is equal to 1 mod p, then 2019 to the 8th is equal to -1 mod p. Since the square root of 1, since 1 squared is also equal to 1, so we cannot just directly. So we find a p right here, then we cannot just directly guarantee that p must be the answer. So we have to check it back in. Okay, so 2019 to the 16 is equivalent to 1 mod p. And how does that help at all? Okay, so now we have to remember Fermat's little theorem. Okay, so what does Fermat's little theorem tell us? So Fermat's little theorem that basically tells us that so if A and B, so if A is a natural number and B and P is a prime, then AP A to the P minus 1 is equal to 1 mod P. Okay. So if you check can know that this is actually true. And how does that even help? So you can see that 2019 to 16 is equal to 1 mod p, then 16 can be written as either p minus 1 over k or p minus 1. So basically, this tells, furthermore, the order of 2019 modulo p divides p minus 1. Since p is a prime. So this only works when p is a prime. Okay, so now what do we do about that? So this basically tells us that a minus 1 is a multiple of 16. Sorry, p minus 1 is a multiple of 16. So basically, p is equal to like 1 mod 16. Okay, so now clearly 17 is the answer, right? However, we have to check it back in since 2019 to the 8th might be 1 mod 17 instead of -17. No, 1 mod 17 instead of -1 mod 17. And we have to check to see if that's actually the case. So 2019 to the 8th, I think 2019 divided by 17 gave us 173, 1, 1, 3, 1. 149. -4. -4 mod 17. Oh, -4 mod 17, which is just equal to 4 mod 17, since -4 to the 8 is equal to 4 mod 8. No, -4 to the 8 is equal to 4 to the 8. That's the same thing. Which is equal to what? 16 to the 4th, right? Which is also just equal to -1 mod, -1 to the 4th mod 17, which is equal to 1 mod 17. So thus we have a contradiction here because we stated that 2019 to the 8th is congruent to 1 mod p, and here it's not the case. So it's equal to -1 mod p, but here we have 1 mod 17, so it's not the case. So let's find the next prime. So the next prime now the next prime 97. So now does 97 work here? So we have to divide again. So 2019 divided by 97 to 194, 194.79. Divided by 97 is like 194.79. Okay, so 79 mod 97, which is like -18. This is just like a lot of computation here. It's like equal to -18 to the 8th p mod 97, which is just equal to 224 to the 4th p mod 97. So 324 mod 97 is just 291 43 to the 4th p mod mod 37, I think. 97. I think I didn't make a computation error. So we can just do 43 square. So 43 square is just 1849, I think. Which is just equal to, which is congruent to 1849. 1849 mod 67 is no, mod 97. Okay, this one's 7, so it's 879 divided by 97. Okay, so 1849 divided by 97 is 197,879. Huh? 67? 6 square? I don't think that's... Wait, no. Okay, it's 33 to the 4th, which is 1089. I think. So 108 divided by 97 is like 119. 22 mod 97, which is equal to -1 mod 97, since 97 times 5 is equal to 485 equal to 44 plus 1. 20 squared plus 1. Okay, now we're finally done. So 97 is our answer. And we're finally done with this problem. Okay, thank you for watching. Hope you enjoyed it, and don't forget to subscribe.